Today we're going to be learning about the two-way ANOVA. Hope you're excited. Here's a brief overview of what we're going to be learning in this session today. So we have the introduction. Congratulations, that's where we are right now. We're going to learn a very specific SPSS skill set called select cases. We're going to do a quick recap and example of doing an independent t-test. We'll also do a quick recap of doing a one-way ANOVA as well as an example with that. Then we will get into the definitions of what a two-way ANOVA is and a full run-through of doing the actual data analysis for the two-way ANOVA, followed by your assignment for this week. So let's get started. Select cases. So we're going to be using this later on when we're doing the two-way ANOVA follow-up tests. So kind of like the Tukey post-hoc tests that we did with the one-way, we have to do some additional tests, and part of that is going to involve this select cases. So I thought we would just do an example on its own that just involved us doing select cases to make sure that you were comfortable with that before we actually start throwing in all of the other stuff that a two-way ANOVA is going to entail. So let's open up session 6 example data file, and we will get right to it. I have the example data for today open up, and you can see we have gender, strategy, and SPSS, not SPSS, SPS. It's terrible to use this variable name when we're dealing with SPSS. Inside here, we have gender, which is nominal, strategy, which is nominal, and then this SPS, science process skills. And you can see the strategies. There's A, B, C, and D coded as 1, 2, 3, 4. And there's male, female coded as 0 and 1. So what select cases is going to allow us to do is basically limit what SPSS will run through a particular test or explore or data analysis. So what we're going to do is actually limit this down so that we're only going to be running strategy 1, okay? So even though there's strategy 2, 3, 4, all the way down here, we're going to ask SPSS to only select the cases that have a strategy equal to 1. And to do that, we're going to go up to data and all the way down to select cases. Once we're in here, we're going to select the if condition is satisfied button right there, and then click the if. What we want to do next is basically give instructions of which thing we want it to select a case of. So I'm going to take the strategy and I'm going to then type in equals 1. So you can type it or you can click the buttons here. And when I hit continue, followed by OK, you can see here it creates this new column, okay? And if I scroll further down, these are now X'd off because their strategy does not equal 1. So this gives us a way to now only deal with strategy 1 and get information just about these people right here that are in strategy 1, and SPSS will ignore everyone else. And if we want to change this, we just go back up to data, go to select cases, click that if button again, and now change it. So now I'll change it to strategy equals 2, hit continue, hit OK. All right, now we can see that strategy 1 has been crossed off, but strategy 2 is still going strong, and then 4 and 3 are all gone. Now, if we don't want this, the easiest way is to select this entire column and just hit clear, and now nothing is selected anymore. And that is how we do the SPSS skill of selecting certain cases. Now we're going to do a brief overview of t-tests, which we're going to have to do as part of the two-way ANOVA procedure later on. So I thought it would be good for us to review how to do this. A t-test is used to compare the means for one variable for two different groups. For instance, in our sample data set that we were just working with, gender would be a variable that has two different groups, male and female. We're going to be focusing on the independent samples t-test in particular, when we're going to be looking for the difference between two groups on some dependent variable. Just a reminder of how to run that in SPSS. We go to Analyze, Compare Means, select the independent samples t-test, and then we move our dependent variable into the test variables, and our independent variable into the grouping variable box. We then have to define our grouping variables. Click OK. And we would have to check Levine's test for equality of variances to make sure that we're actually allowed to use this test. All right, so let's do an example with this. So we're going to use that same session 6 example data file, and we're going to perform an independent samples t-test on gender versus the science process skills. So back in our SPSS data file, make sure that you've cleared the select cases. Remember, you can just select the cell up here and hit clear if you haven't done that already. And to run the t-test, we're going to go to Analyze, Compare Means, Independent Samples t-test. I'm going to move the SPS into the test variables and gender into the grouping variables. We then must define the groups. I will define it as 0 and 1. That is because that is how gender is coded, with zeros and ones. Hit OK, and hit OK again. Here's the output we should have gotten for the independent samples t-test. The first thing that we need to look at is the Levine's test for the equality of variances. And what we're looking for here is for it to not be significant, which means that we want a p-value that is greater than 0.05. Because if p was less than 0.05, then it would say that the variances were unequal, and we are not allowed to perform a t-test with unequal variances. So luckily for us, we have a p-value of 0.2, which is greater than 0.05, which means we are allowed to move on to the next part of this. Here's the next part. We want to look at the actual t-value here, and we have a p-value that is less than 0.001. So we found significance here. We can actually look up at the group statistics to see that the mean for females is higher than the mean for males. So we would be able to say that based on this independent samples t-test, that females have scored significantly higher than males. Next on our to-do list is going over the one-way ANOVA to make sure that we're good to go with that. So the purpose of using a one-way ANOVA is to test the means of 2 or more different groups and whether they are significantly different on some dependent variable. So the big difference between a t-test and a one-way ANOVA is that a t-test can only handle 2 different groups, where an ANOVA can handle 2 or more. Here we have all the steps for running a one-way ANOVA in SPSS. So we would go to Analyze, Compare Means, select the one-way ANOVA, put the dependent variable into the dependent list, the independent into the factor box, and then we have to go through a lot of options to make sure that we're getting everything out of this test that we want. One of the new things about the ANOVA that was different than we had to do with the t-test is that there are follow-up tests that we have to perform. We're lucky that SPSS does this for us in the one-way ANOVA through the Tukey post-hoc procedure, where it basically compares all the different levels of the independent variable for us to see where exactly there is significance, if there is significance. So let's try this out to make sure that you can do the one-way ANOVA. We're going to use the same data file, and we're going to now perform a one-way ANOVA on strategy versus the science process skills. In SPSS, we're going to go to Analyze, down to Compare Means, and all the way over to one-way ANOVA. I'm going to move the SPS into the dependent list and strategy into the factor list. Next, I will click on post-hoc, and I'm going to select Tukey. Then hit Continue, followed by Options, and I'm going to ask it for descriptive and homogeneity of variance tests. Click Continue and OK. Here is part of the output that SPSS would give you. We're going to focus on just this first couple pieces of it to review what's important on them. So the first thing is right here on the test of the homogeneity of variances. And again, this is something that we do not want significance on. And our p-value is 0.75, so we do not have significance. So we can say that the variances are assumed to be equal, which means we are allowed to do the actual ANOVA test down below. So here we have the output for the one-way ANOVA. I've highlighted the sections that are important for us. We have the F-score over here, 5.047. We have the 2 degrees freedom that we need to include in our write-up, as well as the p-value over here of 0.002, which means that we have significance. And if we have significance, we need to perform the Tukey post-hocs. So here are the post-hoc tests that SPSS has run for us. And the first thing that I notice is in strategy B, I can see 2 p-values that are going to be significant. The first is on strategy C. So B compared to C, there's a significant difference between those 2 strategies with a p-value of 0.002. There is also a significant difference between strategy B and D with a p-value of 0.034. Now, there are other ones down here that you might see that have smaller p-values, but this is B versus C, which we have already addressed up here. And there's another one down here, which is B versus D. Again, we've already addressed that one, so I don't need to concern myself with it. And now for the main event. Let's go over what a two-way ANOVA is all about. A two-way ANOVA is used to compare the means for 2 variables with 2 or more different groups over 1 dependent variable, okay? So a two-way ANOVA has 2 independent variables. A one-way ANOVA has 1 independent, a two-way has 2 independent variables. So the purpose of a two-way ANOVA is to test for differences on a continuous dependent variable for 2 independent variables. You can see here we have the data requirements. You need 2 independent variables with 2 or more separate groups. Okay, so we are talking officially about a between subjects two-way ANOVA. I have chosen to ignore the fact that there is also a within subjects ANOVA, just like I did with the one-way last session. An example of what a two-way ANOVA would be if we want to see whether there was a difference between 4 different learning strategies, A, B, C, and D, and gender, male and female, on some instrument. So we have 2 independent variables, the learning strategies and the gender, followed by 1 dependent variable, which is this random instrument that I have not named. The two-way ANOVA has the same assumptions as the one-way ANOVA. We need observations to be independent, we need to be normally distributed, and we need to have the homogeneity of variances. So let's get right to it and start going through the steps for data analysis for a two-way ANOVA. They are, in fact, the exact same steps you've been using before, but there are some modifications now that we will go over. The first is in step 2. There are now going to be multiple research questions, which I will talk about when we get to that slide. Step 3, there's now 2 independent variables, so we need to include both of them. Step 5, because there are multiple research questions, we need multiple null and alternative hypotheses. That's a hard word to say. There are also going to be big differences when we're doing steps 9 and 10. For our example, we're going to continue with the same data set. We have learning strategies, A, B, C, and D, and gender, male and female. We have the science process skills, and we want to see whether there's a difference between learning strategies and gender with respect to the science process skills. Step 1, data cleansing. As always, this has been done for you already. There are no missing values or obvious errors in the data. For step 2, the research questions, we start off with an overall research question. Is there a statistically significant difference between scores of students with learning strategies, A, B, C, or D, and gender, male, female, with respect to mean scores for science process skills? Now, because there are 2 different independent variables, we actually have 2 additional research questions where we separate them out. Okay, so the first one is going to be called the main effect one, where we just say, is there a difference between students with learning strategies only with respect to the SPS? Main effect 2 is there a difference between gender only and science process skills. And lastly, we actually have another research question, which is the interaction between learning strategies and gender. And this would be the 4 research questions that we will have to write when we perform a two-way ANOVA. The overall, a main effect where we separate out just one of the independent variables, followed by second main effect where we use the other independent variable, and then an interaction, which is when we are talking about the interaction of the two independent variables with each other. Please notice the difference in the wording for the last one. It's not, is there a statistically significant difference this time? It is a statistically significant interaction between the scores. Step 3, independent variables. We have the independent variables are learning strategies with 4 levels, A, B, C, D, and gender with 2 levels, male, female, both of which are at the nominal level. Step 4, we have dependent variable. Dependent variable is represented by mean scores for science process skills and is on the interval level. Step 5, we have to do the null and alternative hypotheses. And just like in step 2 with the research questions, we have to break this down into multiple different sections. So we start off with the overall null hypothesis. There is no statistically significant difference between scores of students with learning strategies A, B, C, and D, and gender, male, female, with respect to mean scores for SPS. We follow that up with saying that there will be no difference for just learning strategies with respect to SPS, and again, just gender with respect to SPS. And then lastly, we have that there is no significant interaction between learning strategies and gender. So together, these are the null hypotheses. We follow that up with the exact same thing, doing alternative, now saying that there will be a difference for each one of those original null hypotheses. Step 6, stating the alpha level. The statistic will be tested at the level of alpha less than 0.05. Step 7, type of statistical analysis. We are performing a two-way ANOVA, and you can see I have this 2x4. That 2x4 is stating the levels of the independent variables. So gender has 2 levels and strategy has 4 levels. So we would say that this is a 2x4 two-way ANOVA, and we will use this to analyze differences between learning strategies and gender with respect to the mean scores for science process skills. Step 8, we have to go over all of the assumptions before we're allowed to perform the two-way ANOVA. So we will start off with independence, followed by normality, and then homogeneity. For the assumption of independence, we have that the levels of the independent variable must be independent from one another within each independent variable, not between the independent variables. So what I mean by that is that someone who was categorized as a male was never at any point categorized as a female, and vice versa. Likewise, people within each learning strategy group were never a member of any of the other learning strategy groups. So therefore, we can say that the samples were independent of each other. For the assumption of normality, let's actually jump over to SPSS and perform the descriptive statistics so that we can see where I got all of these numbers from in the table. So in SPSS, I'm going to go to Analyze, Descriptive Statistics, and down to Explore. Once in here, I'm going to move the SPS to the dependent list, and then the strategy and gender to the factor list. Next, I'll click on Plots, and I'm going to actually uncheck the stem and leaf and histogram, and just have it give me the box plots only. And that's just so that our SPSS output is just a little bit smaller. Otherwise, it's going to get a little bit more unmanageable. From there, I will hit OK. And here are our descriptives. The first thing that it does is give us it separate. So we have just strategy A, B, C, and D, and all of their descriptive statistics. So I'm looking at the skewness and kurtosis right here. For all of those, here is a box plot for all of those different strategies. Then after that, it gives me the information based on just gender, so male and female, as well as box plots for those. And what I've done is just taken all of the skewness and kurtosis for each one of those and put them in this chart. And as we can see, all of them are within the plus or minus 1, which means that we have met the assumption of normality. For the assumption of the homogeneity of variances, we're going to allow SPSS to do this for us later on, actually. I will just describe the results to you now, and then I'll highlight it when we actually do the test later on. But here is the output that we got for this. We have an F score of 0.882 with a degrees freedom for the first as 7 and second as 221 with a p-value of 0.5, which means that we do not have a significant difference between the variances, so we can assume that we have met the assumption for the homogeneity of variances. Step 9, computing the test statistic. So we're going to ask SPSS to run this for us. In order to do this, we have to go to Analyze, General Linear Model, and then Univariate. And rather than me reading the rest of these steps off, I think it would actually be better for me to just jump over to SPSS and us to do this example together. So in SPSS, I'm going to go up to Analyze and down to General Linear Model. Okay, so I'm not going to the compare means where we went for the t-test and ANOVA. I'm going one step past that, General Linear Model, and I'm going to this one here that says univariate. From here, I'm going to move SPS to the dependent variable slot. After that, I will move both of the gender and strategy into the fixed factors. Next, we will go to the plots. And what we're going to do here is actually ask it to create a line chart for us that we'll use later on. And it's important that which one we pick for the horizontal axis is the one that has more levels. So I'm going to pick strategy to go here in the horizontal axis because there are 4 levels for strategy. And then I'm going to move gender into this separate lines category. Okay, so the one with the most levels in horizontal, the one with the lesser amount of levels in the separate lines. And from here I have to hit add. That's a very important step. If you don't hit add, it won't actually give us the graph. And then I can hit continue. Next we'll hit post-hoc. And from here, we have to move any factor over that has more than 2 levels. So in this case, that's just strategy. Because gender only has 2 levels, we don't need to do this post-hoc. If there is significance between gender, we can say which one is significantly different by just looking at their means because there's only 2 of them. Strategy, we cannot do that because there are 4 separate strategies, so we need to perform the post-hoc tests for them. Now let's say that you forget and you add gender. SPSS is just going to kick out an error message to you when it runs it saying that it didn't perform the post-hoc for gender because it doesn't make sense. All I have to do next is just hit Tukey and continue. Next we will hit EM means. So this is the estimated marginal means, and I'm just going to select all of these and move them over. You could do it one at a time if you would like, and just hit continue. And what this will give us is just a nice summary of all of the means. It's not actually essential for the test that we're running. Last, we will hit options. I'm going to ask it for descriptive statistics. That's just going to give me a nice summary again, so I don't have to look back at what we've already done. And I will also ask it to perform the homogeneity tests. I will next hit continue and hit OK, where it will actually run this test for us. Here is the SPSS output for the two-way ANOVA. You can see that it just gives us nice little summaries up here of all of the different data for us. So those are extremely useful when we are trying to write our summary statements, particularly this one, which has a breakdown for the strategies and for male and female. Right here is where the Levine's test of equality comes into play. So that is what I used in step 8 when I was looking at the assumption for the homogeneity of variances. And I only looked at the first line, which is based on the mean. I don't look at any of the other lines. The next part is the actual output for the two-way ANOVA. And there are a couple parts that we want to pay attention to and some other parts that we do not care about. Here are the primary boxes that we care about within here. We have gender, strategy, and then gender by strategy. And there is one additional cell for when we are reporting the data that is important to us. This is going to be the second degrees freedom that we use when we're performing the write-up. So let's actually break down what each one of these three things is telling us and actually write the summary statement that we would do in step 10. So this first line here, strategy, this is dealing with main effect 1, which was concerned with whether or not there was a significant difference between strategy as compared to the science process skills. So our summary statement for this main effect is that there is a statistically significant main effect for learning strategy, F 3, 221, so the 3 is coming from right here and the 221 is coming from right there, equals the F score, 5.3, with a p-value equal to 0.002. Next we have gender, which was main effect 2, and that was concerned with whether or not there was a significant difference between gender and science process skills. And as we can see from this output, there was a statistically significant main effect for gender, F1 221, the 1 is coming from right here, the 221 from there. The F value is 19.904, and our P value is less than 0.001. Remember that we can never say P equals 0. We would always say less than 0.001. Now, because gender only has 2 levels, we actually can state right now from this the next part of this write-up, which is that females had statistically significantly higher SPS post scores with the mean and standard deviations, which came from the descriptive statistics charts we've already run, than males with their mean and standard deviation. So all of this sentence right here came from what's highlighted in red on that part of the chart. The last of the 3 deals with the interaction between gender and strategy. So from this line of the two-way ANOVA output, we can say that there was a statistically significant interaction between learning strategy and gender with F parentheses 3, 221. The 3 is coming from right there, 221. We have an F score, which we've rounded to 4.00 and a p-value equal to 0.008. So what this table was able to tell us from all of these highlighted boxes is kind of the overarching answer to the 3 core research questions for main effect 1, main effect 2, and the interaction. So the strategy was for main effect 1, and we found that there was a statistically significant difference because the p-value was 0.002. And now what we need to do is perform post-hoc tests on those to see where exactly that significance lies between strategies A, B, C, and D. So we'll be doing that in a moment. For main effect 2, that came from gender. We also found that there was a statistically significant difference between gender, with P being less than 0.001. And we don't need to perform a post-hoc on that because gender only has 2 levels. So if there's a difference, it's obviously between just male and females. And we just have to refer back to our descriptive statistics to decide which one is higher, males or females. In this case, the females scored significantly higher than the males. Last, we have the interaction between gender and strategy. And we also found significance here, and we are going to have to manually perform follow-up tests to figure out exactly where the significant differences are happening within the interaction between gender and strategy. And we will perform that in a little bit as well. Here are the post-hoc tests for strategy. Now, this is necessary because we found a significant difference between strategy and the science process skills, we need to see where exactly that's happening. So between strategy A and B, A and C, A and D, or any of the other variations. So when looking at this chart, the first one that I noticed was right here. There's a p-value of 0.001 between strategy B and C. And the next one I noticed was right below that between strategies B and D. Now, there are no other significant differences that I can see anywhere else. There are ones here, but this is just a repeat between B and C, and then again down here between B and D. So I already have them covered right here. And from this, I can write another set of follow-up statements. So with those p-values that we just discussed, we can now wrap up main effect 1, which was for learning strategies, by identifying exactly where the statistically significant difference is happening within the strategies. So we can summarize. Students with strategy B had significantly higher scores. And I got the means and standard deviations again from the descriptive statistics above. So they scored significantly higher than students with strategy C. I included the p-value here because this is a comparison between B and C. And now I'm continuing to compare strategy D with B. So I included a separate p-value for the comparison between D and B. Now, if you're having a really tough time with that, separate it out and write it as two separate sentences. One where you compare B and C, and then a second one where you compare B and D. And then I just end it with, there were no other significant differences because we found no other significant differences. To summarize what we have so far, we have now finalized our write-up for main effect 1, which you can see I start off by stating the f-score and p-value that came from the two-way ANOVA output, followed immediately by the write-up that we just wrote. Next, I have main effect 2 and the write-up that I got from that two-way ANOVA output, followed by where exactly the significance lied. And again, I did not need to perform an additional test for this because there was only 2 levels. If there's a difference, it has to be between males and females. Whereas with learning strategies, I needed to see between which strategies there were a difference. Finally, we have the interaction comparison. And what we need to do now is perform follow-up tests to see exactly where the significance lies between the interaction of learning strategies and gender. So SPSS does not do this for us. We're going to have to manually calculate it. But before we do that, let's take a look at the graph that we had SPSS make for us. Here's the graph of the interaction between strategy A, B, C, and D, as well as male and female. So we have the female line is the red one, and the male line is the blue one. And I've added this pink purpley-ish circle here to highlight something, which is that when the lines of the graph are not parallel, which means that they cross, like they do where I have it circled, or they look like they're about to cross, that means that there will be an interaction and that we're going to have to explore this interaction. To explore the interaction, we have to perform a series of t-tests to see exactly where the interaction between strategy and gender occurs. Now, in order to do that, we're going to have to use our select cases and individually run a t-test when we have selected the cases for strategy A, and then run it again when we only have strategy B highlighted, and then again when we only have C, and then again when we only have D. And that way the t-test will only be comparing male and female for strategy A the first time, and then B, and then C, and then D. So we will end up with 4 separate t-tests that we'll have to explore that break down strategy A with its male and females and whether there's a significant difference there, then strategy B, male and females, and whether there's a significant difference there, and so on. So let's jump over to SPSS and select the cases and start running these t-tests. So the first thing we need to do in SPSS is go up to Data and go down to Select Cases. And it just so happens that we already have some of these in here because we've done this example already. But remember, we would click if condition is satisfied and then if we would move strategy over and then say equals, and we're going to change this to be equals 1. I will hit continue and then OK. Now, what this does, to remind you, is it now crosses off anything that does not have a strategy of 1. So when I come up to perform the t-test, which remember, we go to Analyze, and then to Compare Means, and we want to do an independent samples t-test, I don't have to worry about it giving me any results for strategies 2, 3, or 4. It's only going to give me the breakdown of gender versus SPS for strategy 1. Now, we are in luck, and I already had us run these examples, so these are already in here, but remember, we would have had to manually add these things in here, and I can now hit OK. It's going to spit out a t-test, and I'm just not even going to look at it yet. We're just going to continue on. So next I need to repeat this process, but using strategy 2 or B. So I'm going to go to Select Cases, click on If, change this to equals 2, hit Continue, and OK. Now in the data, only strategy 2, which is really strategy B, is being shown. The rest are crossed off. So when I go to Analyze and Compare Means and Independent Samples t-test, I can actually just hit OK because everything has stayed the same. And it will now give me a new t-test that is just for strategy B. And at this point, I think it would probably be good for us to label these. So I'm going to double click on that t-test, and this was strategy B. And I will jump back up to the first one and relabel it as strategy A. Okay, I'm still not going to actually look at them. I'm going to continue. I'm just going to repeat the process now for C. So data, select cases, change it to strategy 3, hit continue and OK. Ask it to do Analyze, Compare the Means, Independent Samples t-test. Everything has stayed the same. I hit OK. I will label this one as strategy C, and I will just move right on into it. Data, select cases, hit the if button, change it to 4, continue, OK, Analyze, Compare the Means, Independent Samples, hit OK, and relabel it. Now, I obviously did that a little bit faster than you might be able to, so hopefully you paused the video and ran each one yourself. And now let's actually go through and see what they said. So here's the t-test for strategy A, and you can see that we first need to look at the Levine's test for the equality of variances to make sure that we were allowed to run a t-test, which we are because it is not significant. Next, we will look at the actual results of the t-test, so that's the second red box. And in this case, we did get significance, which means that for strategy A, there's a significant difference between males and females on the science process skills. And we can actually see they gave us the group statistics right there, where we can see that females were at 6.89 and males were at 4.44. So we can write our summary statement for this, which was females with a mean of 6.89 and a standard deviation of 2.52, with learning strategy A performed significantly better than their male peers, with a mean of 4.44 and a standard deviation of 2.02. And then I also include the t value. So I will include t parentheses 41, close parentheses, equals negative 3.535, comma, p equals 0.001. For strategy B, we'll first look at the Levine's test for the equality of variances, see that we don't have significance, so we can move forward with the t-test, and we have a p-value of 0.06, which is greater than 0.05. So there are no statistically significant differences between gender for strategy B. So we'll just move on from this one. Strategy C, first thing we look at, Levine's test for the equality of variances. We have 0.06 that is greater than 0.05, which means we can assume the variances are equal and we can move on to the actual t-test. In this t-test, we can see that the p-value is quite small, and we can write our summary statement for this. Females with a mean of 5.69 and a standard deviation of 2.29, with learning strategy C performed significantly better than their male peers with a mean of 3.44 and a standard deviation of 1.70. T parentheses 66 close parentheses equals negative 4.563, comma, P less than 0.001. And remember, we never say that P equals 0. Last, we have strategy D. We first look at Levine's test. We see that it is not significant, so we can proceed with the t-test because our variances are equal. And we got a p-value within the t-test of 0.7, which means that there is no statistically significant difference between males and females for strategy D. This is a summary of what I just said out loud for each one of those. So I have the comparison of strategy A, where there was significance, and the comparison of strategy C, where there was significance, and then stated that there were no other significant interactions for the means for gender. So I've actually combined step 10 while we were going over step 9 so that you could see where all the numbers were coming from. So I hope that that was okay, but let's just look at it one last time to officially see it all nice and combined. This is the general outline of the template that I used. You do not need to follow this exactly, it's just a guideline. So for research question 1, which was studying the main effect for learning strategy, we found that there was a statistically significant main effect for learning strategy with all of those fun statistics that we looked up from the main two-way ANOVA chart. Our follow-ups found that students with strategy B had significantly higher scores than students with strategy C and those of students with strategy D. There were no other significant differences. All of that came from this table here and the other table right here. For research question 2, which was dealing with the main effect of gender, we found that there was a statistically significant main effect for gender, and specifically that females had statistically higher SPS scores than males. All of that came from this part of the table, as well as referring back to the descriptive statistics for the means and standard deviations to figure out which one was higher. Lastly, for research question 3, which dealt with the interaction between learning strategy and gender, we found that there was a statistically significant interaction between learning strategies and gender. We included the information from the core two-way ANOVA output. Next was the follow-ups that we performed manually with the t-tests. So we found that females with learning strategy A performed significantly better than their male peers. Likewise, females with learning strategy C also performed significantly better than their male counterparts. There were no other differences between genders. All of that came from this table here and the other table right here. And the last step, step 11, interpreting the results, we had 3 null hypotheses. So we have to talk about each one. For the first one, the null hypothesis, that there was no statistically significant difference between scores with learning strategies with respect to the mean scores for SPS, was rejected. The null hypothesis that there is no statistically significant difference between scores of students with gender with respect to science process skills was rejected. And the null hypothesis that there is no statistically significant interaction between scores of students with learning strategies and gender with respect to science process skills was rejected. And all of those rejections are coming from the two-way ANOVA output. Your assignment for this week is similar, but with a different dependent variable and no longer strategies, but teacher. So we are interested in whether there is a difference between teacher, A, B, C, and D, and gender, male and female, with respect to mean scores for mental focus. You can use the two-way homework data set, which has all of that in it already for you, and you should fill it out using the template found in assignment 5, two-way. Let me know if you had any questions on this, and I'm sure you did, and I will try to answer them in a timely manner for you this time around. I hope you are doing well and surviving with this distance learning so far. And I hope that you're able to find some time to break away from the computer screen to, hang out with your families or read a book or go for a walk or do something to take your mind off of the craziness that is in this world. And I will see you, quote unquote, later, alligators.